Okay, hi. I think this is a test. I'm actually recording this in Zoom, so hi. This is kind of like you missed class. You missed a super exciting class, so now you have to listen to me do a super boring lecture without you. I'm going to try to keep this quick, but it'll probably be 10 minutes long. So the warm-up we had in class today was you've got two spinners, spin one, zoom, spin the other one, zoom, and they come out some colors. And so we got yellow, blue, red, cyan. We've got yellow, blue, cyan. And the question is, what is the sample space for spinning both those? So sample space is all the things that could happen. So one way to do this, and I'm going to show you some examples of this earlier. If I can get my work. Well, one thing that could happen is I could spin and I could get yellows, yellow, yellow. That could happen. Or I could spin and I got yellow, blue. Or I could spin and I got yellow, cyan. So once again, this is my first one, my second spinner. And then maybe instead of hitting yellow on the first one, I hit blue on the first one. So blue, yellow is a possibility, or blue, blue is a possibility, or blue, cyan is a possibility. And similarly, red, yellow, red, blue, and red, cyan, and I'm running out of space. What's our last color? Oh, we can do cyan, yellow, cyan, blue, or cyan, cyan. Those are my possibilities, 12 things. So that is what my sample space looks like. There's more than one way to do it, but just a list like that is fine. So there's 12, that is the sample space, and I might ask you how many there are. There are 12. And so people noticed in class, well, for each thing I've got here, I've got to have one of these things. Since there's 4 things here times 3, I'm going to have 12 things in my sample space. And being able to do that quickly is kind of nice in case I ask a question like this, like what's the probability of yellow, yellow? Well, there's only one of those in the group. I can see there's only one of those in the group. I'm going to change my color here, not the yellow though. So there's one thing out of 12. So 1 out of 12 is my answer for the probability. There's other ways I can write that. And I'm not going to get into the fair odds. We talked about that the other day for our casino. Let me clear all these real quick and scroll down. There's a cleaner version of my answers because I want you to see there's a couple of ways to write the probability here. You can write it as 1 in 12. You can write it as 0.0833333. If you divide the 1 by 12, you can turn that into a percentage. Or if you're just talking to somebody, you very often hear somebody say, well, there's a 1 in 12 chance of that's happening. And then I'll let you just read that for yourself if you want to know about fair odds. What you should have done in advance of not coming to class. Ideally, you should have come to class. But before the people who did come to class, what they were supposed to do beforehand is in the Google Classroom, I had posted a link that looked like this, where there were practice pages. And I think I'm on the right practice page. I am 3. And you were supposed to look at these and answer them. So you should still do that. I'm going to show you some similar kind of questions, but you might try those on your own and ask me a question later if you're not sure if the right answer is. And if you got confused with this, one of the things you might want to do is go to the lesson, which you can actually click here, or you can, there's a second link that I post, but it's easy enough to get there. They can kind of go back and forth. And I want to show you this because part of what's in the lesson is some different ways to do sample spaces. So here we have 3 spinners, and the first person listed all of them out, okay? And that's certainly a good way to do it. The next person, they said, well, I'm going to organize 2 of my spinners in a table, and then I'm going to take the results of that and organize it with the separate table. And this is really nice and neat and makes it really obvious to me that, oh, 4 by 6, there's 24 things in the sample space. And then if I ask you something like, well, what's the chance of the probability of spinning an egg? Well, you can look at this and say, oh, well, there's 12 of those out of 24, it's 12 out of 24, or a 50% chance. So having them all listed out like that is super helpful. And the other way to do it is a tree. And so notice we had 2 things in the first one, and 3 things in the second one, and 4 things in the last one. And we look at our tree and all the leaves, like ALW is a possibility, ALX is a possibility, ALY is a possibility, BX is a possibility. That's just a different way to write a sample space. So it's just nice to know how to write them that way, as well as to kind of be able to read them when they're written this way. Also further down here, there's some general explanation about sample spaces, which you might want to go back and read on your own. but those are some of the resources I've given you to try to get these practice problems done. My guess is in general, most of them will probably make sense, but occasionally they won't, and you should either go back and read the material or just make a note of what your question is. I'm hoping you're writing all these down in your notebook. So I've got some other problems that we didn't do in class for those people who may be tuned in a second time. I do have students who do that, who come to class and then they go back and watch the Ed Puzzle because they really want to know the material well. But that's not where I want to be. It's a long window. Here we go. The probability. Okay, so we have a student that picks a random letter from the word dog and a random letter from the word woof. And the question is, I'm trying to get this thing working here. Annotate. How many outcomes are in the sample space? Well, I could list them all out. I could say, well, it's D and W and D and O and D and O and D and F and then O, and I guess maybe I will list them all out. O and O and no, not O and O. What did I just do wrong? Oh no, this is right. O and O and O and O. Got a little confused there. And O and F, because this is the O and dog, and these are the O's and woof. And then finally, I can do G and W and G and O and G and O and G. Yeah, those are all my possibilities. Now, I'm not sure if I actually needed to do all that. But that's my sample space. And there are 12 things in my sample space, or once again, 3 times 4, because those are what are called independent events. And this is the next question, possibility of getting a D. Well, I can see, well, there's 4 ways out of 12. So that's one way to write it. The other thing I might notice is because this is an independent event, well, there's a 1 in 3 chance, which is what 4 out of 12 reduces to. I'm going to change colors here. Probability of W. So once again, one thing I can think of it, oh, well, there's 1 chance in 4 over here. So that's actually my possibility is 1 out of 4. Or I can look at my whole sample space and say, well, okay, I got W's here, 3 out of 12. That is also 1/4 or 25% chance of pulling the W randomly if I pull 1 letter from each word. All right, this is where these last 2 are where having the sample space is really helpful. Probability that D and W are chosen. I'm going to change colors again. Okay, D and W are chosen, both of them. There's that possibility here. As far as I can tell, it's nowhere else. So that's 1 in 12. And then let me change the colors one more time. Probability that an O is chosen. This is a super tricky one. I'm going to give you a minute. Now my writing's a little difficult. That's actually a D. But there's an O there, 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 there's 1 there, there's 1 there. I think I got them all. So that's 8, 9, 10, 11. No, okay, counting badly. 8. 8 out of 12. Usually we like to write this as a reduced fraction. So those will both divide by 2. That's 4 out of 6. Oh, that'll divide as well. 4 out of 6 is 1 out of 3. And I think I did something wrong. No, 2 out of 3. That's why. 2/3 chance. 75% chance. I divide 2 by 3, I get, wait, nope, not 75. Let me make sure I did this right. That would be 66% chance. And I'm going to pause for a second and make sure I have not made an error. There's 8 things, it's 12. Both those divide by 4, and that works. Whew. Okay, but this is why the sample space is really helpful. You clear that. And I'm going to kill that to go down 1 screen. And I'm going to let you read that to yourself and read it in the side screen. And then I'm just going to put a question up for you. And finally, select all the situations that have a 50% chance of occurring. You're rolling, 50% chance of occurring. So let me get my annotate out here again. So this is like standard cubes, rolling an even number. So, you know, a standard cube is 1 through 6. That's my sample space. So rolling an even number, is that 50%? Yes, it is, because I can do 2, 4, 6. That's 3 out of 6 or 50%. So that one works. Okay. 2 coins and having them both come up heads. Once again, our sample space. Heads, 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 tails, tails, heads, tails, tails. Having them both come up heads is heads heads. That's only 1/4, so that is not 50%. Flipping 2 coins and having the result heads tails. Now, this is a good question. If order matters, there's not an answer. If just getting this combination right is all you need, like I need 1 head and 1 tail, then it is. So this one, it depends. If this was a question on a test, I would be really mad because it's not clear to me what answer they want. But if it's just like if it said getting a heads and a tails, then it would be yes. I think because of the way it's written, it's probably a no. Picking a letter at random from picking a letter random from here and getting an A. So we got 1, 2, 3, 4 A's out of, I think, is 8 letters. So that is a yes or an 8. Picking a letter at random from the word bellow and getting a consonant. So we got 1, 2, 3, 4 consonants. That would be, what are they, 6 things there? Yeah. 4 out of 6 or 2/3. I dreaded 2/3 from last class. That is definitely not 50%. Guessing correctly on a true-false question, yes, that is a 50% chance because our sample space is true and false, and the probability of the correct answer is 1. I don't know how to write that correctly. Okay, I think that's good. Let me double check and make sure I don't have anything queued up here that I want to talk about. I don't think so. I think we're all good. Once again, go back and try to do these problems. You also have a very fun short little quiz that you should take. I will talk to you soon after